Okay, so this is back from chapter 9. Remember this example? We gave students caffeine and a placebo, and we gave them a test to see how depressed they were feeling. Now, this person did both of these things, these two different treatments. And then what do? We subtracted and got a new list and did our t-test with our new list. Well, in chapter 10, what we might do is we want to compare two completely different populations. So in other words, let's see, in this question, we might do something like, let's just see, what about the effects of caffeine on teenagers and the effects of caffeine on people over 40? So two separate populations. Okay, so that's the difference between this type of question and what we're going to do in chapter 10. Okay, so let's take a look at one of these. So this is on page 605, and you might want to look at it, but I'll give you the summary of what's going on here. We have two schools. One school says that 70% of their students did their homework the night before, and a separate school, separate population, says that 50% of their kids did their homework the night before. So then they come up with the standard deviation because they did a sample of 100 kids, and they figured out this, and they took a sample of 200 kids and came up with this as a standard deviation. Okay, so when we compare two populations, a lot of times what we do is we subtract. So we'll subtract these two proportions, and you would think that if we took this school and subtracted from that school, you would come up with a difference of 0.2 between those two. Okay, so, but what about the standard deviations? Now, if you remember way back, see, look at this. You can't just subtract the standard deviations. If I subtract this number from this number, I get 0.0104. Now, that is not correct. That standard deviation is way too small. The way it works is you add the variances and then take the square root to get the standard deviation. Okay, so you might not remember that. That was quite a while ago. But just believe me in the fact that this is how we deal with the standard deviation in this situation. So there it is. This is how we find the new standard deviation. So just kind of like what we did before. This should look familiar, right? Except now the big thing is, don't forget, we add them together. Always add. Okay, so there's that. Let's take a look at a quick example. We're going to do the same one, the same example with the school. Okay. Okay, so based on this situation, 70% minus 50%, the difference should be 20%. Now the counselors report to the principal that they took that simple random sample. School 1 had 200 kids in the sample, school 2 had 100 kids in the sample. Now, when they did this, they came up with a difference of only 10%. So how likely is that would happen, given that the proportions are true? All right, test statistic. So let's work out the standard deviation. So this is what it looks like. It's kind of like our standard deviation of the first group, standard deviation of the second group. We add them together, take the square root of the whole thing, and it turns out to be 0.058. 0.058. Okay, now, just like we've done lots of times before, so we'll say, well, this is what we got, minus, this is what the population says, and we're going to divide it by the standard deviation, 0.058. And we get a value of negative 1.72. Plug that into normal CDF, and you get a value of, well, it's our p-value, right? Of 0.042. What does that mean? That means that if it's true that these two schools have 70% and 50%, and we got a value of just 10% for the difference, there's only a 4% chance that that would happen. So things seem to be a little bit suspicious. In other words, you might conclude that I think that the schools are probably a little bit closer. Now, I don't know if the 70 is less and the 50 is more or whatever. We'll get into that later. Okay, so there's that. It's the same stuff. Z-score over and over and over again. But this time, the only difference is, well, not the only difference, but this is how we get the new standard deviation. We have two separate populations that we are testing. Okay, so that if you, let's see, so tomorrow I see you second period, and we will go from here.